All right, Math 1 back for part 2 of the All About Fractions section. So if you think you know what you're doing, pause the video and try this one on your own. All right, we're back. Did you think to get common denominators? Because that's exactly what you got to do. Ask yourself 5, 6, and 2, what they all share. So if you really have trouble just like visualizing this, my suggestion is to take the biggest of the numbers and start just looking at the multiples of it. So in this case, 6. Does 6 divide 2? Yes, it does. Does it divide 5? No, it does not. So that's not our common denominator. Think of the next one. 12. Does 12 divide 2? Yes, it does. Yes, it does. No, it does not. And you just kind of move through there. So does 18 work? Looks like 5 is going to be the trouble here. The first one that divides 5 is going to be good. So 18 doesn't divide 5. 24 doesn't divide 5. 30, it divides 5. So 30 is going to be your common denominator. So what do we do to get 30? Well, I'm going to multiply 2 times 15 to make a 30 in the denominator there. So I'm going to multiply the top by 15 also. 15 times 3 is 15, 30, 45. There we go. For the 6 times 5 is 30. So I need to multiply this entire numerator also by 5. I'm just going to put parentheses there. So I've got 5 parentheses 2x plus 3. So I'm taking, you know what? Here's an important little piece here. You see the plus that's in front? That plus is connected to the 5 now. So I'm actually taking everything inside these parentheses by positive 5. So positive 5 times 2x is positive 10x. This is an important point that's often subtle and students make mistakes with. Now it's positive 5 times 3. That's going to be positive 15. All right, last one. 5 times 6 is going to be 30, so I'm going to take the whole numerator here and multiply that by 6. So 6 times 3x is going to be 18x. Okay. Now all we got to do is solve everything in magenta. Sorry, if you can't see it on YouTube, it's magenta. So I can kind of say, ditch the denominator and solve 18x plus 10x plus 15. All right, that's everything on the left-hand side, equals 45. At this point, this is where you kind of go to your your default setting of, okay, I got variables, I got to simplify on the left. 18x plus 10x. They're side by side. I don't move them. I just say 18 plus 10 is 28x. The 15, let it be. Notice I did not take 15 plus 45 because they're on opposite sides of this equal sign. I'm going to subtract 15 to move it to the other side so that I zero this out, leaving the x's on the left. So it's going to be 28x on the left. I'm going to move to a different location because I run out of room. 28x on the left plus 0 equals 45 minus 15, which is 30. All right, so at this point, we divide both sides by 28. Remember, division is the only way to get the x by itself in this case. So take out these 28s. It's now 1x, which is just x. And I would suggest you take 30 over 28 and start reducing that fraction before you give your final answer. So if they're even, I can divide the tops and bottom by 2. Divide the top by 2, you get 15. Divide the bottom by 2, you get 14. That's simplified, and the mixed number that's associated with 15 over 14 is 14 goes in there one time. And there's 1 left over, so 1/14 is the fraction tag along. Let's try number 5. Number 6, rather. So I'll write this a little bit more boldly over here. All right, so what do we do if there's a fraction, and then a whole number? Well, to avoid making a pivotal error, let's just make them all fractions. 3 is the same as 3 over 1, and hopefully we'll reduce any weird issues there. So now we ask ourselves, what would be the common denominator between 5, 2, and 1? Hopefully 10 is the one that's coming to mind right away, because that's exactly what it should be. So it's something over 10, something over 10 equals something over 10. So 5 times 2 would give us 10. I got to multiply this whole thing by 2 now. So 2 times 4 is 8. 2 times 2x is positive 4x. All right. 2 times 5 gives me 10. So I'm going to multiply the top. Okay, and this is where things get tricky. The top is now being multiplied by a negative 5. That negative is connected to the 5 that you're multiplying the top group by. So negative 5 times x is negative 5x. Come on now. All right. And then negative 5 times negative 4, positive 20. And then lastly, you take 1 times 10 to get 10. So take 3 times 10. You get 30. And that allows us to ditch the 10s on the bottom and just work with, you know what, I'm going to put it over here so I have more room to work vertically. So you ditch the denominators. And you get 8 plus 4x minus 5x plus 20 equals 30. So the commutative property says that I can move the plus 20 to the 8. These two are already side by side. 4x minus 5x is negative 1x, and you got 30 on the other side. This is 28. Subtract 28 from both sides because it's positive 28. And then you're left with a negative 1x is equal to positive 2. You divide by negative 1. Anything divided by negative 1 just means change the sign of whatever you were dividing to. Just make it x equals negative 2. All right, I think I got a couple more. So this looks like just practice, like similar to what I just did. So why don't you pause it, try it on your own. All right, let's see what we got. 4, 14, and 7. So again, the strategy is, let's try the biggest one, 14. Divide 7, and not 4. 28 would be the next one. 28 divides 4, it's 7 times 4. Got it? So 28 is my common denominator here. 28 equals something over 28. So I multiply this by 7, which means I multiply the top by 7. 4 times 7 is 28, so multiply the top. To get 42 minus 7x over here, 14 times 2 gives me 28. You multiply the top by negative 2. All right, I'm just going to kind of put the negative up here to remind myself. All right, can you see that? You can see that. Negative 2 times 5 is negative 10. Negative 2 times negative 3x is positive 6x. All right, 7 times 4 is 28. So multiply this by 4, you get 32. And minus 8x. You can now ditch the 28s. Yeah, and now I'm going to show you something. I'm okay with you guys taking little itty-bitty shortcuts here, as long as they work out for you. What I mean by that is, instead of actually rewriting things using the commutative property, we can just kind of think through the commutative property in our heads. What I mean by that is, you've got a positive 42 minus 10. I'm not going to require you guys to do that rewrite. Just, what's 42 minus 10? Positive 32. Okay? And then over here, I've got a negative 7x plus 6x. So that's using the commutative property to say we can just add those terms together. Negative 7 plus 6, negative 1x. A second shortcut that you guys are allowed to use is this one. I'm just trying to get the x's on one side and the constants on the other. Okay? So we can technically do that on the same move if you want to. Here's what I mean. I want to get the x terms to the left-hand side. All right? That eliminates those eights on the left. The right. At the same time, I can say move this positive 32 to the right-hand side. And I have to do the opposite operation to make the move count, because it's got to zero itself out. So I zeroed out the x terms on the right, and I zeroed out the constants on the left, and that gives me 7x, because negative 1 plus 8 is 7, is equal to 32 minus 32, 0. Yeah. And it's not a special case. It's not no solution. It's not all real numbers. The x's remain, so you divide by 7, x equals 0. So let's run through one more example where we kind of show how, yeah, we can use some shortcuts and not have so much work written out on the actual paper. All right, this one's pretty obvious. 3, 5, 15. Just make it 15. So, something over 15 equals something over 15. Multiply this by 5, which means multiply that by 5. 5 times 4x is 20x. multiply this by 3 to get 15, which means I'm multiplying this by 3. The negative is connected to the 3 now. So it's negative 3 times 2 is negative 6. Negative 3 times 5x is negative 15x. Notice I'm not even putting an operation between the fractions, because what's on top is going to end up being the thing that guides us. Lastly, nothing changed for the 15, so I don't have to multiply by anything. I guess I could say times by 1, but it doesn't change anything. All right. I have found common denominators. I shall ditch them now. 20x minus 6 minus 15x equals 5x minus 6. So I'm gonna say 20x minus 15x in my head, or off to the side on scratch paper, is 5x. I'm not rewriting it. Oh wow, the left-hand side is identical to the right-hand side. I think I know a special case is coming, but let's just show the moves that makes it happen. Minus 5x from the right, I'm going to move it to the left. I've zeroed out the x's on the right, which means I want to zero out the constants on the left. I'm going to add 6 to zero out the constants on the left. And I got to do it to its like term on the other side. All right, this would be 0x, which is 0, plus 0. This is 0x, plus 0 also. Our x's canceled. That's a true statement. 0 does equal 0. If the x's cancel and it's a true statement, you're left with all real numbers as the solutions. So, all real numbers are solutions to the equation. All right. That was a lot, guys, but I think you guys got the idea, right? Find common denominators. Ditch them because you can use the multiplication property of equality to get rid of them in one simple step. I can just multiply both sides by 15. Those 15s are gone. Yeah. Thanks for watching, and that's all I got.